All right, our objective is to create a simple Verilog module that's going to test whether or not we can download a program to a board, an FPGA board. The board we're working with today is the DE1-SoC development kit. The picture you see here on the screen, right, is a picture of the development kit board. What we're going to do today is we're going to program some of these switches to turn red LEDs on or off. And we're going to use the Quartus software to do this. Now, I've just recently, this morning, installed the Quartus Prime Lite version 18.1 on my computer, right? And I want to make sure that when I install the device drivers, that I did so successfully. And the best way to do that is to say, well, can I plug in my board and connect with my board? So what we're going to do is we're going to start the Quartus software. Here, we're going to create a new project. So click on New Project Wizard, click on Next. Where do I want to save it? So I'm going to click on the three dots. Out on my desktop, I already created a folder named Board Test. Inside that folder, I have a document containing the pin settings, but that is all that's in there. So I'm going to select that folder. I'm going to name the project Board Test. I'm going to click on Next. I want an empty project, no files to add, click on Next. Now I need to select the device, right? The device for the DE1 is the Cyclone 5, which comes up here automatically because it's the only family of devices that I actually installed on this computer. But if you don't know what your device setting is, right, it's shown here in the diagram, but you might have a slightly different chip. There are multiple versions of the DE1-SoC, right? So you could look on your board, and if you look at the chip, this is, right, well, you likely can't see it here on the screen. Sorry. If you look on your particular chip, and I can only make this so big, but you will see the device name, this 5CX, blah, blah, blah. So what we're going to do here is, my device is the 5SCEMA. Let me make this bigger. I'd like to minimize this, but it's not cooperating. Oop. 5CSEMA. I transpose that, and I think I might remember I think it's 5. I think it's this one. Let me take a quick peek here. 5CSEMA. 5F31C6. All right. So I started typing in the name filter, right? The name, I have it on another document that I usually just do a copy paste in here, right? But now that we have our particular device, I'm going to click on Next. For simulation, I'm going to say, use Model Sim Altera, Verilog HDL. We won't run a functional simulation in this, but we will write Verilog. So I'm going to click on Finish. And I'm flying through this because there are other tutorials that go slower and showing you how to create Verilog projects and Quartus projects. All right, so what we want to do now is we need a new file, right? This is our project. You can see our device here has been selected, right, in this project navigator window and the hierarchy tab. But we have no files associated with this. Files tab isn't showing up. That's not real important, but let's go to File, New, Verilog HDL, click on OK. All right. I'm going to run a module. I'm going to give it the same name, Board Test. Our inputs are going to be switches. There are 10 switches. I'm just going to arbitrarily enable 4. So switches 3, 2, 1, and 0, 3 down to 0, SW in all caps. And that is specified by the manufacturer of this board. If you want to connect to hardware, you have to use their settings. Our output are going to be red LEDs, so 3 down to 0. LED R, that's the name of that hardware. Simply going to say assign to the red LEDs the output, the input SW. The bus widths are the same, so I don't need to specify any particular bus size there. And module. All right. In Quartus, you need to save the file the same name as the module here at the top. So is the module name. By default, this is called Verilog 1. I'm going to do a file save as. So it's coming up with the name board test simply because our top level design entity is that. I purposely named the module the same thing too. So let's save that. Oh, no, let's save that. Looks like when I tried to do Control C, I typed just C and got rid of that name. So save this. All right. We could check to see if there's any syntax errors. Don't have to have the word wire. I left that out. Control S. All right. Let's run analysis and synthesis here just to simply check to see if I made any syntax errors. It's going to generate some warnings about not using parallel processors. We can ignore that. As long as we didn't get anything showing up in red, we don't have any syntax errors. All right. Before we program the board, we need to make some pin assignments. If we were to click on assignments, pin planner at this point, what shows up in the pin planner here is our input and output, so our port list, right? Those names show up here in the pin planner, but we have to specify where these hardware names are located on this chip. And there is a very easy way to do this. You could type these in by hand, but that's error prone and time consuming. So we're going to go to assignments, import assignments, click on the 3 dots. By default, it navigated to my project folder, and this is the file that I already had in there. So this QSF file, this Quartus settings file, is for the DE1-SoC. I'm just going to click on open. I'm going to say OK, and it's going to import those assignments into our design. That's something you only ever have to do once. Now, I'm going to go ahead and before we program the board, we have to compile it. That takes a bit longer, so I'm going to double click on compile and get that started. And let's go back and look at our pin planner now. So now you can see in the pin planner that the pin names for our switches and LEDs for our pins in our module have automatically been filled in. And if you scroll all the way down, we have imported an assignment in that file for every single pin on the board. So even though we're not using all those pins, that file has all the pin assignments, so it just imported everything. That won't hurt anything for us, right? Our major concern is that, right, the hardware that we're using on the board does have the pin assignments. I'm going to close the pin planner. Right, compilation takes a little bit of time. It's getting close to finishing. Okay. So it's finished. There were no errors. If there were errors, they would show up in red. There are some warnings. I know that none of these warnings are important to our design at this point, so we will not take a look at that. Now, we can go ahead and click on Program Device. One thing you might want to do is when you plug your board into your computer, right? So let me enable the camera here. All right. Here's my development board, my DE1. It's plugged into AC power. It has a default program running on it then that turns on the 7-segment displays and cycles through the hexadecimal digits 0 through F. It also flashes the red LEDs. All right, so I know the board's getting power. That, and there's also a blue power LED on the board as well. So I know it's getting power, right? I've got the USB plugged into the board and it's plugged into my computer as well. So what we're going to do is Right, we're running here on Windows 10 Home Edition. I'm going to open up, so I'm going to go to search and type Device Manager. Sorry, let me minimize this to make the screen a little more clear. All right, what we expect to see when we plug this in is we should see this as a JTAG device. So I just opened up JTAG cables, and you can see it did detect Altera USB Blaster 2. As a matter of fact, I'm just going to go ahead and unplug this from the hardware board. Notice when I unplug it from the hardware board, of course, that's no longer connected to the computer. That disappears. So if you're not seeing that JTAG device, right, I would say have the device manager on. Go ahead, then plug your board into the USB connection of the computer and see what device pops up. If it doesn't recognize it, typically it will pop up as an unknown device under USB devices, at which point you would have to install a device driver. One way to install a device driver is to select the device, right, and then see if you have options for updating driver or looking at properties, right? I shouldn't have to update the drivers. This was all freshly installed this morning, right? And I can do a different tutorial on updating the driver because this has recognized the device at this point. All right, that's what I was concerned. Does Windows recognize the device? We're good on that one. Let's go back to Quartus here, right? And we can just click on this to program the device, open the programmer, sorry, double click. And that brings up this window. All right. Now, when you compile, you generate, or sorry, Quartus generates. Let me open up this. Quartus Generate, so this is that folder board test. It created a folder called output files. We can see there are quite a few files in here. What we're looking for is a file with the name of our top level design followed by SOF. Right, so we're going to need that SOF file, which was part of the compilation step. Right. We could click, in this case, on Start. Now, first take a look at hardware setup. If it's the first time you're doing this, you may see no hardware. So typically, this is what you're going to see the first time. Right? So if you see no hardware, what you do is you go to Hardware Setup. We've already confirmed that Windows sees our JTAG device's USB blaster. So we simply go to this drop-down menu, select DE1-SoC, click Close, and notice now that this has changed here. So then we can, what you could do is, it looks at this point like we've got an output file. This box is checked for program configure, right? It looks like it's found our SOF file. What happens if we hit Start for start programming? It failed, right? The DE1-SoC is a little bit different than some of the other boards. What we're going to do is we're going to click on Auto Detect. That brings up this select device. We want 5C SCMA 5. So we're going to click on that. Right. We get this message about the auto detected device chain does not match the programmer's device list. Do we want to update the device list, overriding any existing settings? Yes, we do. All right. So now we have what looks like 2 chips here. Right. What we want to do is let's click on the 5C SCMA, and we want to click on then change file. And now this brings up our project folder. Double click on output files. It just narrows in. It's just looking for an SOF. So click on open. And so now we've brought this SOF file in here. Check program configure, and now press the start button. What we're looking for is, if it takes a while to upload, the progress bar will turn green and slowly upload, but you can see that it's 100% uploaded to the board. It says 100% successful. Let's switch the camera. Sorry, move the camera back over to the board now. Right. So you can see, well, I need a better camera setup. All right, you can see, right. Nothing there's no lights on the board. That's because all my slider switches are in the off position. If I were to take switch 0 and press it forward, I'd turn on LED 0. I'm going to do the same for 1, 2, and 3. Right, so those are in the on position. We've turned on the LEDs. And this is what we wanted to confirm, right? How do we program the board? Even after it says it was 100% successful, right? Go ahead and test the hardware on the board to make sure that your design uploaded and works as expected, right? But that was just a good, quick test then of how do we program the board, especially for the first time, to make sure it detects the device driver. All right, and so if you were successful, that's all you really need. Otherwise, I'm going to close the programmer menu. Oh, when you close the programmer menu, it created this new tool chain. It asks if you want to save it. You can save it. And if you do, then you could just reopen that again to use it for this. So if I had to go back and fix something and maybe re-upload again, I might save it so that I don't have to go through these steps again. But for now, I'm just going to say, no, I don't want to save those changes. Right. For anyone having problems with your board, I'm going to go back to Device Manager. If you didn't have any problems, don't need these steps. But so here under JTAG cables, if you're having problems and you're not seeing the JTAG cables, right? If it's showing as an unknown device, like I said, you want to right click on it. You likely have the update driver option. You could go to the properties option as well. Properties option tells me the device is working correctly, right? It gives me the same ability to update the driver from here. So I could click on that. Right. Now, if I decided I wanted to update the driver, let me make sure. What I want to do is I'm going to say browse my computer for drivers. And where I want to look in the C drive where this software was installed. So let's go to browse. C drive, let's see. I was expecting to have a folder called Altera here. I didn't expect it to be under drivers. Program files. Let's see if I can. I used to install things under. Oh, Intel FPGA Lite. That's where it is. Sorry, before Intel bought out Altera, everything was called Altera. I need to get with it. So Intel FPGA Lite, and then it's going to be under 18.1, the path, and then under Quartus, right? And then under drivers. Don't drill down any lower than that. I'd say okay. Now you can say next, right? And in this case, it's telling me the best drivers are already installed. Otherwise, it should find your driver in that file and then install it for you and recognize the device correctly. All right, so hopefully you're able to program your board for the first time as well. Good luck.